Welcome to the OpenUSD Insiders live stream. We are very excited to have a couple of very special guests here from the Isaac Lab team. They're going to go over importing assets and creating scenes in Isaac Lab. For those who may not be familiar with the Isaac Lab, it's a unified framework for robot learning built on NVIDIA Isaac Sim. We're going to go more into that in a few minutes, but before we begin and introduce our very special presenters today, I want to go over a quick few announcements because we've had so much excitement over the last few days about NVIDIA's CES announcements. So on this slide, you can see several announcements right there. We're going to post a link, which brings you to our forum post on CES announcements, which links to each specific blog. Obviously, AI was a big part of CES this year. We announced Mega, Cosmos, early access for Sensor RTX, a lot of great work shown off on digital twins in XR, and of course generative physical AI, which was a very big theme for Jensen's big keynote. We also at CES launched Cosmos, the World Foundation model. It's a platform to accelerate physical AI development. We're super excited about this. There was a great article actually just posted on Forbes. We'll put that in the chat as well. We'll also send a link to this full announcement. For people who are interested in talking more about Cosmos, we have a great channel on the Discord called Generative AI, and there's a thread on there discussing Cosmos. A lot of great videos already on YouTube and LinkedIn, people diving in. Super exciting work, really accelerating robotics development and lowering the barrier to entry and making it more accessible to developers worldwide. So super exciting. We're just amazed at the work we're seeing come out of Cosmos already. And for those who want to take the next step and do some learning, we have our new Learn OpenUSD courses, our Series 200, so to speak. We mentioned this last week on the live stream. We'll post a link in the chat. Basically, you have two full series now, 100 and 200 series, and more coming out very regularly. These are free courses to help you get into the fundamentals of OpenUSD. And if you're an expert or you're just new to OpenUSD, there's something this course is really there for everybody. So we hope you'll join in and dig into them. And you can also welcome to discuss the OpenUSD learnings you have, and the courses are on your own in our weekly OpenUSD study group, which is hosted by our community member, Nandu Valal. That happens every Tuesday. Check our ad event calendar, which we'll post a link for in a minute, if you want to add it to your own calendar very easily. I highly recommend it. It's fun. We also have announced the OpenUSD-based simulation synthetic data generation for advanced robot learning. We'll post a link here. There's also been another study group, which is happening on Wednesday, focused on Isaac Sim and Isaac Lab. We're going to be focused on Isaac Lab today, but if you want to dive into the study group, it's going to be happening in about an hour and a half from now, if you're watching this live. So again, that is on our event calendar. It's also on our Discord server, and the events in the upper left, and that's a great way to talk about these announcements and more with other people who are really closely working on Isaac Sim and Isaac Lab. Okay, I think that's it for these slides. So I'm going to go to our very special guests. We've got two colleagues here. I will let each one introduce themselves along with their background at NVIDIA. If you've been watching these live streams for a while, these are no strangers to the live streams. They are veteran hosts now on the live stream series. Very happy to welcome back. We'll start with Asari. Hey, Asari.
Hello, everyone. My name is Asavari, and I work as a tech marketing engineer at NVIDIA on some of our robotics and simulation platforms. So today we're going to be, me and my colleague Goinda Mola, who will introduce herself. We are going to be talking a little bit about how to get started with Isaac Lab. Very excited to be here.
Very exciting. And we'll talk about this in a second, because I think some people might need a little bit of, if you're just coming across Isaac Lab for the first time, maybe we'll define what the difference between Isaac Sim and Isaac Lab is and how they work together. But before we do that, thank you for joining us. Really excited.
All right. Thank you so much, Edmund. Thank you, Asawari. Okay, my name is Oyindamola. I'm also a technical marketing engineer for Isaac Lab, working on all the reinforcement learning, imitation learning initiatives that we have currently today. So,
Very exciting. And I can't tell you how many great comments we got live and also afterwards from your last presentation, which was so full of information, super helpful. So we're very excited for this hour. So this format is office hours. So even though we're going to be showcasing how to import assets and creating scenes, we welcome your questions throughout this hour. That's really the main purpose of this. In addition to showing off a new feature and how to do some workflow, we want to take your questions live. As long as it relates to Isaac Lab, if you have an Isaac Sim question, we'll try to answer with a link in the chat. But for the live discussion, we want to keep focusing on Isaac Lab as much as possible. Say hi in the chat. Let us know where you're watching from. If you've got a project you're working on, let us know. That's always great to also share that with the community watching, and maybe you'll meet a good partner to work with you in the chat as well. And you can always carry on discussion on our community Discord server for this live stream and others if you go to the live streams channel. We'll post a link for that in the chat. Without further ado, I'll pass it off to my colleagues here, and I'll be hanging out in the chat, and I'll pop in sporadically as needed. So have a great hour.
Awesome. Thank you, Edmar. So welcome everyone to the Isaac Lab office hours. We do this about once a month, and the objective is really to listen to your questions and try answering them live so we can discuss more in detail as well. For more detailed questions though, wherein maybe you've started working on Isaac Lab and you're stuck somewhere or you need help debugging, we'll share a chat, but we encourage you to share those kind of questions on the GitHub issues so that we can actually share log files and help you debug even further there. But this is a great place to kind of start, like for starter questions, and when you're just starting off, you may have like more fundamental questions about how does this work, or like how can I even do this in Isaac Lab. This is the right place to get all of those things clarified. So in today's office hours, we're going to, of course, spend some time on questions live. And we're also going to be talking a little bit about how to get started with the basics. So step one, when you start using Isaac Lab, is to import assets and create a scene in Isaac Lab. So we'll talk a little bit about, we promise we don't have too many slides today, just one or two to set context. But once we get through those, it's going to be a more hands-on session where we're going to be sharing our screen, walking you through some of the code, and launching Isaac Lab live so that you can see the examples. So let's get started. I'm going to start sharing some of our slides for today to set context. This is good. Okay. So in the last Isaac Lab office hours, we showed something called a reference architecture. This is basically a high-level understanding of the entire workflow. So it includes the reference architecture itself is available on the Isaac Lab documentation site. And it walks you through things you can do using Isaac Lab, basically all the use cases and the features that it includes to achieve those things. And it also walks through all the different components that are part of the entire workflow. So as you can see on the screen right now, there's a lot of different parts to it that all work together. Today we'll be focusing on the first part of it, which is in that green box that you see. This section focuses on getting input into Isaac Sim. So Isaac Sim is our simulation platform. And the first part of the reference architecture that we'll be seeing today is how to create a scene, a very simple scene in Isaac Sim. And a scene here just means a simulated environment. Some examples of more complex scenes would be a warehouse environment. So if you're working on, say, warehouse logistics operations, and you want to simulate or create a digital twin of a physical lab or a warehouse in simulation, that's an example of a more complex scene. But today we'll be creating a fairly simple one with just a ground plane and some lighting. So the first part of the box that you see here is the input, where you create that scene and you create the robot assets that you will be using. Now, again, there are more complex robots we can look at, like humanoids or quadrupeds. Today, we'll be looking at a very simple robot, which is called the cart pole. So it's really just like imagine a cuboid with a pole, and we'll be trying to do some things with that very basic robot going forward. Now, the second part of it is the configuration, where you actually define via some Python files, you define the configuration of the robot you're importing. So everything included in this configuration will be the robot motors, actuators, articulation, and that is very closely modeled to the physical hardware of the robot. So that's the idea. The configuration is what actually helps you bring the physical robot into the simulation format. So that's the box you're seeing over here. And let's jump into a little more detail in the next slide. But just going forward a little bit, we'll be talking about the other parts of the pipeline in the next few office hours. And those other parts will then use this created scene and created robot to actually design a reinforcement learning task or a function, and then actually simulate those things to train a model or a policy. So going forward, we're zooming in a little bit on that first phase over here. What we're going to see today, hands-on, is how to create an empty scene. And then you can create this using a config. So there are two ways to do it. In Isaac Sim, you can do it using the UI as well, and also using like Python files. So we'll be seeing the latter part today. Then you write the robot config. Now, the beauty of this part is that there's a whole bunch of robot configs that are already kind of inbuilt into Isaac Lab. So for those, you can literally just use them as is for all your quadrupeds, humanoids, more basic robot formats. Where the other, like the beauty part of it is that you can bring your own robot as well. So if you have a robot not already part of Isaac Lab, you can write the config file for it and import it and use it with all the physics and the simulation in Isaac Lab. So after you have your robot config, you can import that into the scene. And then in the scene, you'll be adding some basic primitives, which will be like the ground plane, different lighting, different camera positions. Once you have all of that ready, you can launch the scene in simulation. And launching it basically means you play it, and then all physics is enabled. So if you have some things levitating, they'll fall down like due to gravity. Those kind of things are the physics part of it. And then photorealism comes in when you're trying to import the assets and add lighting and things like that. So today, what you're going to see, the image that just came up on the right, that's the example of the cart pole robot, which is a very basic, we're spawning multiple over here in this example, but you can just see the ground plane, a couple of the robots, and then we'll try to, in the next office hours, as we proceed subsequently, we'll be training some simple policies. So some prerequisites over here. If you have Isaac Sim and Isaac Lab installed already, that's awesome because you can actually follow along live while we're showing it today. If not, these are the links provided over here to install Isaac Sim and Isaac Lab. And once you have those things installed, you can start running the example and go back to the tutorials or watch today's office hours again and follow along at that point. So what we're going to see now is a quick kind of like a demo wherein we will be seeing the code and the actual how to do it later. But for the next 5 minutes, I'm going to show you a quick preview of what it looks like just to make it a little more exciting. So you can see what are the kind of things you can do with Isaac Lab. So what we're looking at right now is, it's called Showroom Demos. You'll find it as a tab on the Isaac Lab documentation. And over here, we're going to be spawning a very simple scene, again, with some quadruped robots. So quadrupeds are these dog-shaped robots from different companies, a bunch of our partners. And we'll be spawning a scene and looking at some basic code that enables us to do different things with this eventually. So I think what I'm going to do is first launch the example. And you can see, so okay, if you have Isaac Lab installed, all you have to do is go to your local directory. This is an example that comes preloaded. So go to your installation of Isaac Lab and run the script. And the file that you'll be running is, you'll find it under standalone demos quadrupeds.py. So let's go ahead and run this example. It takes a couple of seconds to load. And what you will see very soon is a bunch of different quadrupeds. And they aren't really doing much other than they're basically spawning periodically in the scene. And they're kind of standing or balancing and then spawning again. So that's all we wanted to show via this example. But now on the right here, we're going to look at some of the important lines of code to get started with this. And feel free to start posting your questions in the chat. I see some already, and we'll start answering those as soon as we can. Okay, so the first line we want to focus on is some of the import statements. This is important. So over here, I'm going to highlight a couple of lines, but all of these import statements essentially are pulling the robot configuration from the respective file. So animal is one type of quadruped, spot is another type from Boston Dynamics. Then you have some of the unitary quadrupeds. Each of these have a separate robot configuration file, which we'll be learning how to write today. And once you've written that, you kind of import it into any scene that you want. So that is why these lines are especially important. And then some of the functions include define origins. So this is defining the scene and where it originates in Isaac Sim. All of this code is available on GitHub. So if you at any point like to go there, check it out, maybe tweak it. We'll also see an example of tweaking some of the code right now. Feel free to do so. We design a very simple scene. It just includes the ground plane and some lighting. And of course, you can add, this is where you'd add more things as you want the scene to get more complex with different objects. There are arguments that you can change as well, like the light intensity. We'll also show you very soon how to add arguments. So if there are more parameters you'd like to tweak, that's something you can add via code. And that's the kind of value add of doing all of this via code. So of course, you can do it via the UI as well, the Isaac Sim UI over here, which is great for like at the beginning when you're just getting started. But eventually, when you want more like fine-grained control over your scene and setting it up, you would want to go to the scripting examples that we have. All of these lines of code over here are, like you see, origin with animal, origin with unitary. These are calling the different robots into the scene and setting them at specified locations as well. And then eventually, we're just returning the scene with all of these robots in this format. So it's a fairly straightforward code. And you can, of course, in this way, you can add more robots as well. It doesn't have to be quadrupeds. You can add different types of robot configurations as well. Run simulator is an important function because this is where we actually start the Isaac Lab environment. And we're resetting the sim time. This is the time that's captured in simulation. And we're setting the robot, we're spawning the robots repeatedly. Over here, an important line that I'd like to show you, which we will be tweaking pretty soon, is this line. It's setting the robot joint positions. So what it's doing is, you see the robot spawning and moving a little bit. That's because via this random function, we're adding some randomness to the robot actions. There is a scaling factor over here, the 0.1 that you see. We will be tweaking this very soon to a higher value just to see what happens. But the idea here is that you can randomize the action and tweak it accordingly. And it can be any action, like for a quadruped, walking or locomotion may make sense. For the cart, for example, it'll be balancing the pole. So the kind of action will vary based on the use case. Going down, let's just take a quick look at the main function. Over here, you're setting the camera angle. You're calling the scene and the robot that you had designed in the prior functions, and then you run the simulator. This is the important thing here. And then once you're done, you close the simulation app. So there are some lines that you'll see in all the codes and different files that you run throughout Isaac Lab. And these are some of the important ones. So now take a quick minute to observe the action here, how the quadrupeds are behaving. And real quick, I'm going to change the value of the random function and then run the file again. And let's see what happens. Okay, so I'm going to change it to, let's say, 5.1 instead of 0.1. And then run the file again. So it's that easy. You can just change the value in the code, save that code, run the file again, the same way we did before. What do you guys think is going to happen? Let us know in the chat. There you go. So they're all behaving a little more erratically now. And that's just because we increased the scale of motion. So each motor or each action that was happening is kind of more pronounced now. And of course, you can change it back to the original value. We can cancel this. And then change it back to whatever it was, save the file and run it again. So it's as easy as that. And through this example, we just wanted to highlight how quick it is to start developing with Isaac Lab, because you can make minor changes in the code, save it, see how that reflects the robot behavior. If it's acceptable to your use case, that's great. If not, you can keep tweaking iteratively. So this is what development looks like when we get started. So hopefully this example was just intended to get you excited, and hopefully we did that. If you go lower down in the showroom demos, you'll see more examples as well. So quadrupeds was one, but we have an example for, I believe, arms, robotic hands. So these are all very easy to just run one line of code and you can see the different examples happening. So this would be a good place to get started. Now I'm going to pass it over to Oyendamola, and she's going to tell us a little more detail about how to write this robot configuration that we saw. So we'll be doing it for the cart pole, and we'll also be seeing how to create a very simple scene to start using Isaac Lab. Any questions, please let us know.
All right. Thank you, Asa. Thank you, Lynchian AI, for helping us to answer some of the questions. That was really good. Okay, so I believe one of the things we want to learn really is how to use Isaac Lab if you're starting from the beginning. We have definitely the tutorial, like the documentation part, where a lot of information has been put in here for us to be able to use Isaac Lab and then to use to train, either using reinforcement learning or using imitation learning. So quick one. So we have different section of the documentation. Getting started involves just how to install Isaac Lab, Isaac Sim. First, of course, if you want to get through the documentation, the first thing is to look at getting started to install that. Then, of course, if you want to go straight diving into using it, you want to go straight all the way down to the tutorial. So today we're going to go through some section of the tutorials just for us to be able to know how to how to create a scene, and also how to write the robot config and then import that robot into the scene. So creating an empty scene is the first thing we're going to start with. And creating an empty scene in Isaac Lab, basically it involves importing some set of APIs. Okay, so what I will just try to do is that I'll try to see if I want to create an RL tax, where do I start from? First, I need to know what the tax is. Like if in this case, we are looking at a simple tax of a cat pool trying to balance itself. So the first thing you need is to create that cat pool in Isaac Sim as a simulator, and then use Python APIs to be able to interact with that GUI or with that environment that you create. So this tutorial shows us how to be able to launch and control Isaac Sim Simulator from a standalone Python script. So definitely you need Python background to be able to do anything in Isaac Sim, Isaac Lab. I think somebody asked that question earlier, that do I need a Python background? Yeah, definitely you do need that, because most of the things that are written here are interacted using Python. So yeah, we're going to look at how to create an empty scene using the App Launcher API and also the Sim simulation context. So the very first thing we want to look at is the app launcher wraps around a particular API in Omniverse Isaac Kit app. So that Omniverse Isaac Kit simulation app is a class that is used to launch the simulator. So the first thing, of course, you want to do is to import the app launcher, which is from Omni Isaac Lab app right here. And then you create a set of CLI argument. So one of the things is that we already have default CLI argument that you can set using the arc parser, and that can be seen in any Python script that you run. You can actually see what the list of the CLI argument is by just running the. Okay, so this is for create empty scene. It's good to know that all this code I'm going to be running is inside of standalone tutorials, and all inside of that folder you see different kind of functions or Python scripts that are there. So I'm just running the first one, which is the create empty scene. So if you want to see the arc parser, so dash help gives you some outputs, giving you different kind of environment variables that already default using the app launcher. So the first one that is very most important for us is headless. So headless is used for instance, if you want to train a particular robot to do a particular task, but you don't want to see the GUI at every training episode. You just want to run your training, but you don't want to see the GUI. So that's why you use the headless CLI argument. And of course, there are other kind of arguments like live stream. Enable cameras helps you. For instance, you want to be able to record your scene into a video so that you can see how your training iteration progress per episode or per iteration. Then you can enable cameras and all of that. So of course, device, do you want to run it on CPU, GPU, or if you have multi GPU, which of the GPU do you want to run it on? And of course, there are other different kind of arguments that you have here. But if you're training, one of the arguments that you might want to add to this list of arguments is the number of environments when it comes to vectorization, or you want to scale up your training. So parser.add argument is a function that you want to use. Of course, if you're familiar with arc parser, you know that you need first of all the name of the arc parser, what type is it, what is the default value, and maybe some help functions. These are optional, but it helps to be able to know that. So if I have that and I uncomment this line and save that, if I run that same, you will see under options, you will see that list, this particular argument that I added. So of course you can add as many arguments as you want based on what you need for your particular task. So that's the first thing. Now that parser is then added as an object inside app launcher, and then we create a particular variable called arg underscore CLI equals the parser underscore args, and then when you put that arg CLI into the Arg launcher, then app launcher.app. This line alone is needed for just launching the simulator. So I've just basically just covered how to launch the simulator. So I'll try to run it without going through the rest of the code. So I'm going to just comment the rest of the code. Nothing's going to break, don't worry. So what you're going to see is just as simple as the app running. The app just loaded, but definitely it's going to close because I didn't have it to probably loop or do anything like that. So that's all about it. So of course you need to first launch the simulator before doing anything. So you can go through the rest of this tutorial and just look at, okay, how do I add more command options, user defined command options, how do I do all of that into this place. And also there's a next tutorial that says deep dive into app launcher. That helps. If you go through this particular tutorial, you will see, okay, what are the environment variables that I have, adding arguments, the arc parser, understanding the output of dash dash help that we actually looked at, and then using those environment variables. What does headless mean? What does live stream mean? And then code execution, you'll be able to execute what does it look like if I run headless, what does it look like if I run with live stream. So I'm just going to try running it with just one parameter, which is headless, and then we can see what does that look like. So what that looks like is that my simulation is definitely going to run, which is setup is complete. So the simulation is running, and then what you see is that the simulator, the GUI is not up, which is good. How do you know it is running? I know, like, okay, how am I sure it's actually running? If I close that, and I'm just going to try to print something right in this line, because this line is actually the main function runs the simulator in a while loop. So I'm just going to try to print. Okay, what is this? We are doing Isaac Lab office hours, and then I'm just gonna try to print that, and okay, our office hours. Good. I hope I did not remove any part of the code. And then what you should see is that it keep printing that. So that shows you that the simulator is running, even though you don't see the GUI. So this is very important if you're doing training, because of course you don't want to be running the GUI for every part of your iteration when you're training, because that kind of slows down the training. All right. So the first part we just covered is just how to launch the simulator. Now let's go back to creating the empty scene. Now, we actually do not just want to just launch the simulator. We want to put things in the scene. So to start with actually configuring the simulation context, the first thing you want to do is to import some Python modules. Most of the Python modules or sub packages that you need for simulator related operation are found in the omniisaac.lab.sim. And that is what we imported here. We imported two classes. That's the simulation config and the simulation context. One thing about Isaac Lab is that we should be very comfortable seeing the CFG, because most of the things are written in config files. So when we import that in a sync config, if you're going down into what the code actually looks like, you set a bit of parameters, like things like what's the physics print part, what's like the device you're trying to use. Some of these are already default. What's like the delta t, like how what's the time step that you want to use to run your physics. Like we all know, this is about running physics, right? If you have like how do I know my next position? My next position equals to my current position plus velocity times delta t. So delta t is very important to be able to do that. So then of course now the next thing is, okay, the simulation context itself. Now when launching the simulator from a standalone script, the user has complete control over playing, pausing, and stepping the simulator. Now all these operations are handled using the simulation context. It takes care of different various timelines and also configure the physics scene for simulation. So in Isaac Lab, the simulation context class inherits from the main Isaac Sim omni Isaac call dot simulation context to allow for configuring the simulation using Python data class. I know that's a whole lot of words, but basically, if you want to start, you want to reset the simulation, you want to play, you want to pause the simulation. That's all of those functions are already inbuilt into the simulation context. So the first thing we want to do here is to set the camera angle, and this is very random. Like you can definitely change it when you when you run the simulator. But just to set the camera view, what does the position and the orientation of that camera view, what does it look like? And that's what you can set here. And then for the creation of the simulation context, we only configure the physics acting on the the simulated scene, which include the device to use for simulation, the gravity vector. You know, if you're simulating things on Earth for the Earth, of course, your gravity is like 8G. But of course, if you are looking at simulation for maybe other part of the planet, that's a different gravity vector. And also and also some advanced solver that you actually need to be able to solve your parameters. So the two main steps to run your simulation is that you design the simulation scene and then you run the simulation loop. So for here, because it's an empty scene, we're not putting anything in the scene. So that's all about it. So this part of the code helps you to be able to play the simulator and also run the simulator. So sim.reset helps us to be able to number one, like what is written here, the first thing you want to do to set up your simulation scene is to call this reset function. The method plays the timeline and initiates the physics handle in the simulator. It must always be called first time before stepping the simulator. Otherwise, the simulation handles are not initialized properly. So there are different handles that handles, okay, how does it come out in the GUI? How does it undo the physics step? How does it do all of those things? And that is all done in this reset function. I like going into each and every of these functions to be able to see what exactly is the function actually doing. And of course, we are programmers, we like to know what things are done, you know, in grain and things like that. All right. So lastly is while the sim app is running, I believe if you do a lot of maybe some simple gym or some simple maybe like you are doing rows and things like that, there's always this while something is running, and this is so that the simulation app keeps running. Then step to be able to perform the physics step, and finally if your if underscore main dot main equals underscore main underscore, and then you run your main function, and finally you close this app. So that is a very simple way to create an empty scene. Well, like I said, what we are mostly concerned about is not just to create an MC scene. You know, we are mostly concerned about how do you actually put something in the scene, and that's the next thing we're going into. So I hope this just gives you a very brief introduction into how to interact with Isaac Sim itself using the Python API from Isaac Lab. All right, so the next thing, if you're a user that you want to go into, is to go through this next set of tutorials. Spawning prim into the scene, div dive app launcher. Now from spawning prim into the scene all the way to interact with the form objects, it helps you to be able to interact with most of this object one at a time. Like we are trying to spawn one object, like what Asari kind of showed us the other time. So you spawn most of the object individually, like just one object. But in the case whereby you want to spawn like thousands of objects at once, you might not want to do it manually. And that's why we create an API, you know, if a class called the interactive scene. And then we're just going to go into how to use the interactive scene and then see how to create a scene using that and then run that in simulation. All right. So thank you for following all the way to now. And I hope we are all dropping our questions and they are being answered. Thank you, Asa, for looking into the chat. All right, so using interactive sim. Now, so far in the tutorials, okay, it's interesting because I didn't go into the remaining part of the tutorials. There's a part of when the lecturer tells you to do something, but teach you something, but there's also the part of assignments. So that I think that's our homework to just go through the previous tutorials. But I'm just going to the next one. We manually spawn assets into the simulation and created the object instances to interact with them. However, as complexity of the scene increases, it becomes tedious to perform this task manually. You want to be able to create one line of code that spawn like thousands of robots at once, and that's what we want to do. So at eye level, an interactive scene is a collection of scene entities. So an entity can either be a non-interactive prim, like a prim that you're not articulating, you're not changing the velocity, you're not changing anything. For instance, a ground plane, you're not changing anything, it's just a ground plane. It shouldn't move. If the ground plane is not there, things are just going to fall and keep falling all the way down. And also, those are non-interactive scenes. prims. Then interactive prim are like articulation, rigid object, sensors, things that you need to move from one place to another. So compared to the manual approach, it provides the following benefit. The user, first, the most important thing is that the user doesn't need to spawn each of the assets separately and doesn't need to spawn it for multiple environment line by line. Like if I want to spawn 20, I'm not going to write 20 lines. So to enable user-friendly cloning of the scene prims, that's one of the reasons why we use interactive scene. And then you'll be able to collect all the scene entity into one object, and it's easier for that. It's easier for you to be able to manage that way. So let's go to the code. And this is going to be interesting. I really wish we kind of pre-inform people to just bring their PC and try to change some things, remove some things, and let's go on with that. But it's fine. We're still going to go ahead with it. Since this is recorded, you can always go back to the video and then look at it and try to do whatever we did right here. I'm sure some people have gone through this tutorial and are really like, probably training things right now. But this is just for those that are just starting off and see how to be able to navigate the documentation and all. Okay, so we've gone through this first part of the code earlier, which is just to launch the simulation app. So all the way in this place. The only interesting argument that we had here is the norm environment, because we're dealing with interactive scenes. So we want to be able to spawn a particular robot in thousands of environments. So that's a argument that we can add here, which is the norm environment. The next thing is to import touch by touch. We need some of the utils from there. Most of the predefined assets that we have in Isaac Sim are all the configurations are defined in the sim utils. So the interesting part about the file structure in Isaac Lab is most of the code in Isaac Lab is inside of source. And then inside of source, you see 3 different folders: apps, extension, and standalone. So standalone is where we have most of these tutorials inside of there, benchmark, workflows, like the algorithm that I use for RL and all of that. But extension is actually where we have 3 kind of extension right here: the Omni Isaac Lab, which is for main and core functions; the Omni Isaac dot lab assets. So this is where we define most of the configuration files for robots. And then the lab tags, based on a particular task you want to do, manipulation, locomotion. This is where we define that. So because we're trying to get asset configuration, we are importing from Omni Isaac Lab.asset. You import 2 kind of configuration files. One is the articulation configuration, which is for the interactive frame. So if you want to articulate your particular object, you need to take this articulation config. Then the asset-based config are for prims that you do not need to interact with. All right, so I'll go back to the scene configuration. So the scene comprises of a collection of entities, each with its own configuration, like I said. And then these are specified in a configuration class that inherits from interactive scene config. So for the catpole example, we specify the same scene as the previous tutorial, but now we list them in the configuration class. So right here, I'm going to come back to this real quick. And then we've seen this import file for the simulation context. We see interactive scene, definitely, because that's what we're looking at right now. You import the scene and import the config file. So straight away, you want to create your own robot. Let's say you have a jetbot, or you have a custom robot that you want to create. You can just call a class, of course, add config, call a class, the name of the scene config. So for instance, we're dealing with catpole. So we have catpole scene config, and it inherits from interactive scene config. The first thing we want to do is to import the ground plane. We call it variable called ground equals to assets base config. So like I said, asset base config is for objects that you don't have to, like non-interactive frame object. So if I go into asset base config, what do you see? You need to define the initial state of the config of the asset you want to put. They are definitely default 1000 and just and the rotation, the type of asset that you want, the prim part of the asset. Prim part is basically the part of your either your USD or your the prim part expression that you need to your asset actually. Like that's the name that is going to be showing on Isaac Sim as the name of the object. So for instance, if you want it to have like the parents like world, you have /world/ the name of the robot. Then of course in spawn is where you actually give um the parts, different kind of configuration to be able to spawn that robot into the scene. So let me just close that real quick. So the print part not necessarily is not the path to the USD. Let me correct that, the USD file, but just the path for you to be able to spawn that robot into the scene. So /world/default ground plane. So when you open Isaac Sim, you're going to be seeing this as a name. Then the spawn the simutils.ground plane config. If you go into the ground plane config, you'll be able to see, yeah, this is actually where you see the USD part. Most of the assets, like somebody asked, like, where do you find most of these robot models? Most of them are inside the Isaac Noclus directory, which you can actually find in the Isaac Sim documentation where this part is created. All right, because of time, I'm just going to go ahead to go into the other type of assets that we have. So the next one is to add lights. It's necessary for you to add lights when you're when you're training, so that you can see everything that you have inside of it. All right. Then of course, if you have a particular task whereby you need to spawn some assets that we have, for instance, you have a spare. If you decide to spawn, you want to spawn a spare, just calling the spare equals to the asset base. Put the print part of that spare. You want to spawn the spawn function, which defines a particular config file for that. I would like to run this particular file first, so that we can see what we're talking about, because it's like, okay, I'm just looking at code, I'm reading through it. But before we do that, I would just like to go through this part of explaining the print part. One of the things you can see is a key difference to note is the specification of the print part for different prints. Now, for the ground is /world, light /world, the spare is fast world. But when it comes to the articulation, or if you want a particular um, assets to be spawned in like thousands of environment, then you don't use /world. You use this particular environment called env_red_ns. So as we learned earlier, Omniverse create a graph of prims in USD. Now the prim part are used to specify the location of the prim in the graph. Now the ground plane and the light source are specified using the absolute path, which is /world. That's the absolute path. While the catpo is specified using the relative path. So the relative part is specified using this variable, which is a special variable that is replaced with the environment name during scene creation. So any entity that has this particular variable will be cloned for each of the environment. And this part is replaced by the scene object, which is /world/ems_high. So I'll show you a difference between that. So this is a spare, and I'm just using the print part /world, which is the absolute print part. If I decide to run that, so this particular tutorial is in _o2_scene/create_scene.py, and if I decide to run that, okay, I did not save that particular file, so I might have to run it again. Okay, I'm going to close that. All right, let me save that file. So like what we've been doing since is just defining the scene configuration that we want. So if I use just the absolute part, what you're going to see is you're just going to see one spare that is just defined right here. So that's all about it. So I didn't define the position of the sphere. You can definitely define that using the initial state variable right here. You can define that. But so right now the default is 000. That's why you're seeing it at the center of the screen. Now, if I do not want it to just be spawned in I do not want just one spare to be spawned. I want several spares to be spawned. Then I change it using the environment. I use the env_regex_nx variable for me to be able to do that. And now this responds to the num environment, which is a variable that we defined right up here. Now the default is 2. That's why initially when I ran it, you saw just 2 catpo running. Now if I come here and then I do the num environment to be equals to like 32, what you will see is that interesting. What would you say? I would like to see somebody put it in the chat, but I think I'm going to run it real quick. All right. Now someone is like, oh, nothing spawned. Yeah, that's because I did not save my file. So I'm going to go back, close this, and then save my file. So it's always good to save your files. Now this happens a lot where you type something and then you don't see it happen. Then you realize that the issue was just Control S. So please always save your file up so that you can see the changes that you particularly need to see in the simulation. Okay, while I wait for this to close, the other one is this is a specific part, which is the next part, which is of our tutorial today, is to add, like, to talk about robot config. Oh wow, so time is not on our side anymore. Okay, I'm just gonna try. All right, I'm gonna run this again. Okay, I'm just gonna run this again and try to run through this particular tutorial. All right, now you see what happens. So the spare is being spawned at 32 environment, 32 different environments because of that particular function that you used. Now, how would you want to use this? For instance, if you have an environment with like a table, like a manipulator and all of that, you would not want to use the absolute path to be able to define that. You want to use this particular variable to define that. All right, lastly, let me go into robot config. Now, the catpole is the name of the robot that we need here, right? And it's using the articulation config file because it's a interactive frame. Now, for every robot that you want to import, you need a config file for it. So the catpole underscore config is the config file for the catpole. So we're going to look at that real briefly, and then I'll just show if you want to create your own. If you have your own UST or URDF of your robot, how do you import that into Isaac Sim? So most of the all of the config file are inside the folder omni.isaac.lab underscore assets. So if you go to the extension, you see omni isaac underscore dot omni.isaac.lab underscore asset. Go to omni isaac lab asset, then you see a lot of configuration for most of the robots right here. So for this one, it's catpole config. Now, catpole config uses the articulation config. Now, how did you write an asset config? There is under the auto guides in the simulation, auto guides, you see write an asset config. So writing an asset config is as simple as defining the articulation config and three different variables: the spawn variable, the initial state, and the actuators. So the spawn variable takes in the file, the USD part file. So for instance, if you have like your robot, let's say jetbot.urdf, this is where you specify that. You can specify it locally if you have it locally, or specify it if you already put it in the Isaac Lab no plus directory. That's good. Then of course the rigid body, you specify the rigid body properties. If you want the rigid body to be enabled, what's the maximum velocity and all of that. Then the articulation property, do you want it to enable self-collision? What's the solver position count? Now, if you go to each and every of this code, you'll be able to see what parameters can you set for you to be able to use that. All right, then finally, the initial state of the robot. All of the information are right here in this documentation. What does initial state mean? What does actuators configuration mean? So there are definitely different actuators that you can use. Most is the implicit actuation config right here. When you click on it, you'll be able to see that it's a PD controller and all of that, a PD control. And of course, you can have different controller for different things. So this is for catpole. If you look at the one for humanoid, it's almost the same thing. You define the spin, the spawn, the initial state, and the actuators. And of course, each of the actuators have different joints. What's the name of the joint that is inside of it? For a humanoid, you have the waist, the upper arm, and things like that. So when you define all of this, you go back to the scene, you import that particular config. So for instance, the catpole is imported here. I also imported the humanoid one. So I'm going to run just the one for the catpole for now. And then when I run the code, what I see is that I see like 32 because I put number of environments to cost 32. I'll see up to 32 catpole spawn. Don't worry about the spare. I think I did not remove that out of. Okay, yeah, I did not remove that because I didn't save that, but that's fine. So you see 32 robots spawned right here. So I'm going to close that, and finally I'll show what does it look like if I have my own robot. For instance, I have something else. I name it as whatever I need to name it as, and then take the config file, place it, define it, the config. Of course, dot replace the print path needs to be defined right here, and can just be as simple as slash robot. So and then I can define that and then run that. So you'll be able to see. Okay, now there's going to be an error, and this is the reason why the error is there. Now, when you define your articulation, there's okay. Okay, I didn't save that. Okay, I don't keep saving. Okay, all right, I'm going to close that. When you define an articulation, there's a name to which you define the articulation, and that is the name you're going to use to access the robot. So right here, because catpole is commented, I can use catpole to access that. You can see that unknown word is written right here, and then I go back to humanoid, change the scene to humanoid. That is the only time I can actually access humanoid. So if I run it and then if I run this, it access the robot. The delta T, we've actually spoken about that before. So what you see is text to humanoid right here, and of course the number of environment is can be changed. You can like put like, let's say, I don't know, let's say 300 environment, and you see a lot of that. So we've gone through how to this run simulator code already. It's the same code. The only difference is that you can choose to add different kind of joint effort right there, like random effort, different kind of things that you can add there. Then the main function, same thing. You have the same config, set your camera. You call the design scene. For the previous one, it's if you have just the you call the scene config rather that you created before, you call the interactive scene, and this is used for many other things that you can define. All right, fine. So of course you can see almost like 300 environment. All right, I think that is what we have here in terms of creating a scene, importing, having a robot configuration file, importing that robot into the scene. And you can then go through the rest of the tutorial whereby you have, okay, now I have my scene. Okay, back in tutorial. Where now I have my scene, I need to create a RL environment, either management-based direct workflow. So most of the time, what you see there, the only difference in what we just showed right now, and that is that now you have your okay, oh, great. Okay, so now you have different kind of things like the reward function, you have termination function, and you have other things that you can define inside of it, and then that is that you put together as an RL environment. And then you can look at other tutorials that we have here, and that should get you started in training your own particular robot. Someone asks a question about adding sensors to your robot, right? You have a documentation right here on how to add sensor to your robot, and then how to modify different kind of environments that we have before is right here. All right, I hope this particular section was helpful for us. I think we'll just go to questions right now.
So this is a great segue into, we did have a question about direct workflow versus manager-based workflow. And I thought we'd discuss that live, so I kept it towards the end. So here's the question. It says, documentation mentions the direct workflow may bring more performance benefits compared to manager-based workflow. Is it significantly faster?
Okay, that's a good question. So I mean, most of us, if you're starting out from scratch, you're mostly familiar with the direct-based workflow. Then the management-based workflow, it helps to be able to like divide most of the tasks into different config and then bringing it together. And then we handle most of the logic for you. Now, is it significantly faster? Personally, I've not necessarily checked either one is faster than the other, but I would say that you have more control about your logic in direct based workflow if you want to do complex tasks. So if you want to do complex tasks, you can go for direct based workflow. But if you want for prototyping, you can just do the management based workflow.
Awesome. And then we had a follow-up question about something related to the same thing. The question was, which workflow is generally preferred, direct or manager-based? And do you know what professionals or researchers commonly use for their projects of the two?
Okay, I think the bane of this question is like, should I just go straight to direct based workflow and not bother about management based workflow, or should I just go to management based and all of that? Okay, all right. So which one do people use? I believe it's a thing of preference. depending of preference, that's what we use. Like I said, for mostly maybe like large companies that want to prototype what they need, management-based workflow is what they will do. Because they're not trying to maybe in the middle of, for instance, say I want to change the way the robots relate in the middle of a particular episode. Like if I want to run 200 episodes, or out of 100, I want to do something different. Now that is not coded into the management-based workflow. So you want to go to that base workflow. So which one do people generally use? It's really up to your preference. And I would just say it's good to learn both of them. And then based on whatever you want to do, you can choose which side of the goal you want to use. Yeah. So do you know what professionals or researchers commonly use for their project or research? Let's get out of this question. Okay. I think we've answered that.
Okay, I think we do have some more time for some more questions. So I see one over here. Okay, it says, is it possible to create new joints and articulations for bodies that are not defined in the robot config file, such as an external box, which will interact with the robot? So yes, any external object or any external robot also that you want to interact with your robot, all of those definitions or specifications will be in the config file in Omni Lab Assets, I believe. I had shared the link earlier in the chat. So yes, you will kind of create a separate config file for all the things that you want to be in your scene. And then this is how you will import all of those into your file.
Yeah. Okay. Just to give an example for that, if you look at this particular example, this is a lift tax. So if I go to the available example, just environment, just to give a picture to it. So this is this particular tax right here. So you can see the robot as like a cube that it has to interact with, or this particular one that it has a cabinet to interact with. So you can create each and every of those asset configs separately. So for instance, the table is created here, and then the robot is also created I believe somewhere here, yeah, right here. And then with that, you can use you can have separate config for each and every of those articulation. You can have more than one articulation, definitely, that in a particular sim. And then that's with the sim.physics step, you should be able to run the physics for that.
Okay, one more question. It's about importing a camera asset from Unreal Engine into Omniverse. So the question is, if you wanted to recreate the camera in USD, and then can you copy paste code from Unreal into Omniverse? I think it's not as straightforward as just like copying and pasting it. Personally, I haven't tried this before. Oenda Mola can go right after me and let if she's tried it before. But I think you'd have to maybe at least go through the initial tutorials about how like what the format would look like, what the code would look like in the Isaac Lab context as well.
Oh, okay. Okay. So I have to recreate a camera in USD model and copy paste coding from Unreal Engine into Omniverse. I think that's how the question is. Okay. So if you have like a camera model already created in a different format, like I said, there are different formats right here that we support in terms of if you want to transfer from one format to another format. Like you don't have to use USD or inside it there's like maybe like a URDF file that you have, then you just convert from URDF to you use your URDF directly, or MuJoCo or MJCF, you can use that directly. But if you have things like OBJ, FBX, and all of those extensions, you can convert them using most of the converters that we have on Isaac Sim Isaac Sim documentation. If you go to the reference architecture right here, you can see asset config, and then you can see how to import different, how to convert one asset from one file to another file. So you don't necessarily have to copy all your code, copy and paste. You just need to see what file am I converting from. I hope that's actually what the question meant. But yeah, that's what we have for now.
Okay, I think we maybe have a minute more to get to some of the questions that came in now. Okay. In an object collection, are there any methods to get the current position of only one of the objects? So I believe I've seen we have a similar question and discussion on the Isaac Lab GitHub as well. So if you'd like to go check that discussion out and see how, I think it was very similar to what you want to do. Yes, I believe there are methods to get the current position of only, I believe it's returned as a list of all the objects in the scene, but you should be able to tweak that to get only one of the objects as well. Oyenda Mola, do you know if there are any direct ways to get just one of the object positions?
Okay, so in the example we just showed, like I said, most of the assets are accessed by the name you used to create the asset. Please pardon me for that. Okay, so for instance, for cat pool or for humanoid right here. So the scene, the scene is a dictionary that is returned, and then you can use the name of that particular uh, object to be able to get that scene. So this is for robot, and then on that robot you be able to see, like for me, for instance, it is written right here, robot.data maybe default joint velocity. If you want the current velocity, you can have things like robot.data. For instance, this is the joint position of the particular robot at a particular time. So there are other data, I believe. If you go down inside there, you should be able to see like current position. So one of the things I do is I try to go inside each and every of this object and then see inside every of this object, and then see what are the parameters that are listed inside there. And that's how I'm able to get the position, the current position of that particular object. So it's just a matter of just accessing it using the name you used to create the object.
Okay, I think with that, we have reached the end of our office hours for this time. There are a couple of links in the chat for all the upcoming office hours as well for Isaac Lab and Isaac Sim. And we've also shared some links to the interesting tutorials that we've been coming out with for robot learning. Edmar, if there are any more closing remarks.
Well, I guess first of all, that was awesome, both of you guys. That was not, and also awesome was all the great comments, the questions, and the answers provided not only from Asari, who was a trooper in the chat, but also some of the users in the community had some great answers, including Shane Reitz, who also has produced some fantastic video that I highly recommend checking out his YouTube channel, who covers great components of Isaac Sim and Isaac Lab as well. I also, as seen on the screen, I wanted to remind everybody this incredible event that's coming up in quicker than you know it, GTC. And as it says right on the screen, what's next in AI starts here. We hope you'll consider attending GTC. It's an amazing event, a global event that we host, that we're going to have sessions. There's going to be obviously keynote from Jensen. If you scroll down here, if you can just go to nvidia.com/GTC. Where we list a lot of the speakers and the sessions that have already been announced, more coming, of course. There's some example sessions there. It's just an amazing opportunity to not only learn and engage with others, but also to network with your fellow users in the community and with NVIDIAns and with our partners. So it's going to be a great time. If you are going, let us know in the community team. If you're headed there, we can invite you to some special things that are happening. You can always reach me, edmar@nvidia.com. Any questions, just feel free to post on Discord. And again, I sorry you mentioned this earlier, but we have the discussion thread. That's where you want to go probably for support for Isaac Lab and GitHub. So that link is posted in the chat. Just do a search for Isaac Lab GitHub, and then once you're there, just go to discussions at the top, and then you'll be in the right area. And that's a great trove of information there. So thank you both for presenting today. Amazing job. And if for those who want to continue on diving into Isaac Sim and Isaac Lab, we actually have a study group taking place, I believe, in a half hour that's going to be hosted on our Discord with NVIDIA's Eric Bowman and other members of the community. So I hope you'll join us there. Put the link in the chat, is in the Ed event calendar. Otherwise, I hope everybody has a great rest of the day, and we'll see you next time. Thank you.